Hello, guys. Welcome to Ramta Solutions. Welcome to your exam prep series on forces. So, this is a topic for grade 11 physical sciences and, of course, grade 12 physical sciences. The question paper that we're looking at is the grade 11 physical sciences of November 2023 from the Eastern Cape province. Okay. So, without any waste of time, let's read the instructions of what exams want from you. Instruction number 8. By the way, before I proceed, remember all of the instructions are important, but we're going to highlight these ones that we want to use now. Instruction 8. Show all formulae and substitutions in all calculations. Number 9. Round off your final numerical answers to a minimum of 2 decimal places. Okay, to a minimum of 2 decimal places. Okay, all right. Then what do we say? Then we say instruction number 10. In fact, with this one, we need to expand on it. We need to expand on it. In the middle of your calculations, please do not round off to 2 decimal places. In the middle of your calculations, if you happen to round off, maybe leave it to, let's say, 4 to 5 decimal places. But your final answer is the one that should be rounded off to 2 decimal places. Okay, perfect. Instruction 10, give brief motivations, discussions, etc. were required. Instruction 11, use the attached datasheet. It's not for the question that we want. Instruction 12, you are advised to use the attached datasheet. This is if you forget your formulas or your constants, you can always refer to them. Instruction 13, write neatly and legibly. I know the neatly part is subjective, but it's important, guys, that in as much as we improve our understanding of the laws of physics, we must also ensure that our presentation or the presentation of our work is neat. Okay, so we should also work on improving our handwritings. Okay, perfect. All right. This is a grade 11 paper, so obviously the section topic starts at question 3. So let's see now. Now, question 3, a constant force F pulls a 20 kilogram block at a constant speed over a rough horizontal surface XY. This means we are expecting a frictional force, as shown in diagram A below, okay? The coefficient of kinetic friction, see what I said? The coefficient of kinetic friction between the block and the surface is 0.2. Perfect. 3.1. Give a reason why the coefficient of kinetic friction has no unit. It's because it is a ratio of 2 forces. Okay? It is a ratio of 2 forces. All right? Remember, let me use a different color here to explain. Remember, let's say kinetic is equal to coefficient of kinetic times normal force. When you look at this, you can say it is frictional force over normal force. Do you see this? All these are in newtons, Newton over Newton. This is why it doesn't have a unit. Okay, perfect. Proceeding 3.2, draw a labeled free body diagram showing all the forces acting on the block. They are your normal force of gravity, your friction, and the applied force, which is at 30 degrees from the horizontal. Right? Perfect. Now, 3.3, state Newton's first law of motion in weights. Oh, we are cruising. Right, Newton's first law of motion in weights. And here, by the way, I prefer that you write dashes. Newton's first law of motion in weights. An object continues in its state of rest or in uniform motion unless acted upon by a non-zero net force. In its state of rest or in uniform motion, unless acted upon by a non-zero net force. So you see, now we're cruising. We're supposed to finish this question in 19 marks. And by the way, because this is a grade 11 paper and a final exam, the video is gonna be long because there's about 4 questions on forces. Okay. 3.4. Calculate the magnitude of 3.4.1 of the normal force. So we're gonna look at the first. We know F net equals ma. So now let's look at the horizontal. When we look at the horizontal, we can see it will be the component of the force in the horizontal minus friction equals ma, right? So in the horizontal, we will have F sub x minus friction equals ma. Okay, equals ma. So this is constant. You guys remember, right? This is constant. So what do we say? If you recall, this is kinetic friction. So we say this will be mg cos theta minus, let me say, mu sub k multiplied by the normal equals ma. So what is this? In fact, let me not say, it's not mg, man. I don't know why I'm saying mg. It's not the gravity. It is the force, right? It is applied force. So horizontal component of the applied force, as you can see, it is here. It'll be cosine because it's adjacent over hypotenuse, hence it's cos. Okay, now substituting, we have F cos 30 degrees. What is the coefficient? They said it's 0.2. We do not know what the normal is so far. Don't be confused here when I say I do not know what the normal is, because you're thinking that it is equal to mg. It is not. Okay, it is not, and I'm going to show you, because the forces in the vertical are not just weight and the normal force. It's not just that. There's also vertical component of your applied force. Okay, now this, they said, where is it? It's moving at a constant speed, so it means the acceleration will be 0. Okay, so let's see now. I'm not going to simplify this as yet, so I'm just going to say F cos 30 degrees minus 0.2 n, not newtons, n for normal force, is 0. So F is equal to 0.2 over cos 30. What is this? You can write it as 2 root 3 over 15. It's okay, but you can also write it as 0, what is this? Is this 30 or 35? Oh, it's 35. Oh, it's 35. Sorry. It's 35. It's 35. So it's 35. So it's 0.2442 n. Right? Guys, I'm tempted here. I want to, instead of saying n, I want to say f sub n, because I think it's going to confuse us. Even myself, I end up making that mistake. F sub n, let me call it f sub n, because really it's going to confuse us. Okay, times the normal force. Okay, perfect. Now in the vertical, let's look for it in the vertical. So in the vertical, what are we looking at? So in the vertical, we will say, when we look at it in the vertical, we will say, in the vertical, we will say, again, it is f net comma y equals ma y. Okay, in the vertical, we have the normal, let me call it like that, plus f sub y minus f sub g, which is equal to ma sub y. Normal, let's wait for it. And what is this? And in fact, we should change this one, but it's fine. Let's see. This is F. It will now be F sine, let me call it theta, minus mg equals ma sub y. So this one, we can change it, and let's look at it. When we say, um, um, uh, I don't want to, but it's okay. It's okay. Yeah, it's okay. I will just work with it. No worries. F sub y. It's okay. I will work with it. I just wanted a substitution that will simplify my work. So let's substitute now. What is F sub n? We do not know. I'm going to leave it like this. We do not know. What is F? They said wherever we see F, we must put 0, 2442 F sub n sine 35 degrees minus 20 times 9.8 equals 20 times 0. Okay, perfect. Now, let's see now. We have F sub n minus 0.2242 times sine 35. What is it? It is 0.1286 F sub n minus, this must be 196, I believe, equals 0. 20 times 9.8 is 196, correct? Okay, so 0.1 minus 0.1286 will be 0.8714 F sub n equals 196. So 196 divided by 0.8714 will be, just hold on for now. Okay, what is it? Is it minus or plus? We need to be careful here. It's a plus. Yes, it's a plus. You see now, it's a plus. You see now, it's a plus. So this is not really, well, it is 1.1286. Remember, guys, it's a plus because normal is going up, F sub y is also going up. Okay, this is what I wanted us to be careful of. All right, happy? Perfect. So let's see now. We said 0.2442 sine 35 is, aha, you see, perfect. So this is 0.1401. Okay, then this part here becomes 1,1401 F sub n. Now 196 divided by 1.1401 is, let's see, F sub n is 171.9147 newtons. Therefore, F will be, check what we said there, 0.2442 times F sub n. 0.2442 times 171.9147. What is it? 171.9147. What is this? So it tells us that our F is 41.98 newtons. Okay, 41.98 newtons. That is force F. Happy? Perfect. 3.4.2. What is the normal force? You see, we calculated it. It is normal force is, let me just call it like this. Oh boy, normal force is, hold on. Okay, normal force is 171.91 newtons. I will say calculated calculated at 3.4.1. Okay, now 3.4.3. What is the frictional force? What is the frictional force? Remember, now the frictional force F sub k is equal to mu sub k times the normal force. What is it? They said it is 0.2. And what is the normal force? The normal force is 171.91. Let's see now. 0.2 times 171.91. What is our answer? 34.38 newtons. 34.38 newtons. Happy? Perfect. Right? This is great. Now, 3.5. Let's see now. 3.5. The same horizontal force is now applied to the block, over the same rough horizontal surface as before at an angle of 50 degrees with the horizontal as shown in diagram B below. How will the frictional force of the block in diagram B compare with the frictional force of the block in diagram A? Right, only higher, lower, or remains the same? Before we get there, guys, we need to explain. I will explain. This is why you are watching this video. Remember, in the horizontal, we had Fn plus, what was it? It was F what? It was F sine theta minus mg equals 0. So this means your normal force will be mg minus, check, minus F sine theta, isn't it? Now, check what your sine graph looks like. Your sine graph looks like this. This is your 90, 180, 270, 360. Okay. Right. However, we are interested in the 0 to 90. Right. We're interested in the 0 to 90. All right. So, the question that they're asking you is this. When how will the frictional force compare with the frictional force at A? All right. So here, what is happening? I want you to see something here. Remember here, the angle is decreasing. So as the angle is decreasing, check this out. As the angle is decreasing, this means your F sine theta will be getting smaller. When it gets smaller, what's happening? It means mg minus F sine theta will be getting bigger, and therefore your normal force will increase. But remember, normal force is directly proportional to friction. Therefore, to answer your question, it will be, since your normal force is increasing, it means then your friction will increase. So your answer is simply higher. It will be higher than that one there. So it will be higher. That's your answer. Why? Because as it's going that way, what's happening? The sine theta is decreasing. Right? Sine theta is decreasing. Now, as it decreases, the F sine theta decreases, and therefore, what does it mean? If the S sine theta decreases, it means the mg minus F sine theta increases. And when that happens, this therefore means the F sub n will increase. And because of this relationship, it means the friction will be higher than what you had. Okay, perfect. Now, we're done with this. With all the yada yadding, we were able to finish it in 19 minutes. Now, let's go to another one. Let's see now. Question what? This is question 4. So we can start it here. Question 4. In the diagram below, an 8-kilogram block is connected to a 4-kilogram block by means of a light inextensible string. A constant force of 55 newtons is applied to the 8 kilogram block to accelerate the combination of blocks to the right. Okay, cool. The kinetic frictional force between the 4 kilogram block and the inclined plane is 4 newton, while the kinetic frictional force between the 4 kilogram block and the horizontal plane is 8 newtons. Oh, okay. Interesting. State Newton's second law of motion. Yo, 2 marks. When a net force acts on an object, 2 marks. When a net force acts on an object, the object will accelerate in the direction of the net force. I think I can squeeze acceleration here. Will accelerate, yes, in the direction of the net force. This acceleration is directly proportional to the net force, and inversely proportional to the mass of the object. Oops. Okay. This is it. Our 2 marks. Now 4.2. Draw a free body diagram of all the forces acting on the 4 kilogram block. I will show you 2 ways. It is experiencing tension in this way, normal in this way, and perpendicular to normal is, or opposite normal, not perpendicular. Opposite normal is F perpendicular component of gravity, and then it's also experiencing horizontal component of gravity. And not just that, there's also friction. Or you can say it is weight and then normal force and then tension and then friction. Okay. All right. You can draw any of them. Okay. Now 4.3. Calculate the tension in the steering connecting the 2 blocks. I'm gonna focus on the 4 kilogram block. The 4 kilogram block. For the 4 kilo, but before that, we must have said F net equals MA. I like writing my net to indicate that it's a subscript, so it's not one word. Okay, so when we look at the 4 kilogram block, we had it in this way. As you can see, tension minus friction minus F sub gx equals MA. Okay, they say we must calculate the tension in the steering. Okay, and before we do that, let's confirm. That means to accelerate. So acceleration is not 0. Okay, moving on. We then say this is one friction. We know what it is, and this guy, it will be mg sine 30 degrees equals ma. Okay, so now let's substitute. Tension we do not know. Friction for the 4 kilogram block, they said you are 4 newtons. The mass is 4, gravity 9.8 sine 30 equals 4a. So we have tension minus 4. This is 2 times 9.8. You guys have calculators, but this is simply 19.6 equals 4a. Okay, equals 4a. So if you like, we can say timer. tension is equal to 4A plus 23.6. Please confirm. 2 times 9, 2 times 9.8 is 19.6 plus 4, it's 23.6, correct? So this is equation 1, good. Now for the 8 kilogram block, they didn't ask us for the free body diagram. I like drawing it so you make sense of it, okay? So this is your applied force, which is, let's call it applied. So let's just call it F. And then it experiences tension in this direction and then friction in this direction. You are force of gravity, you are normal. So we have force minus tension minus friction equals M sub A. So what is this? It is 55. What is the tension? We said the tension is 4A plus 23.6. So it's going to be minus because it's minus here. 23.6. And the friction is 8. The mass is 8. The acceleration we do not know. All right? Okay. Proceeding. We have 55 minus 23.6 minus 8. Right? Minus 8. Minus 8. I want to make sure that here I am not speaking gibberish. I just want to confirm here. Okay, just want to confirm here. We have 4 minus 4 into 9.8 sine 30. Oh. Let me see. I want to confirm. I don't want to make any mistakes. So, okay, this is good. This is good. This is good. Right, okay, this is good. Right, this is good. So there is no mistake so far, isn't it? Let me see. Please confirm, guys, if there are any mistakes. I don't see any mistakes. Yeah, it's okay. So perfect. So for A plus 23.6. All right. Let's move on. Yes, let's move on. So we have now 55 minus 23.6 minus 8. It's 23.4. This is 23.4 equals 12A. So divided by 12, it will be 1.96, isn't it? It'll be 1.96, right? It'll be 1 point, but we're not done. Acceleration is 1.9667 meters per square second, right? That is the acceleration. So we have to substitute it on equation 1, right? So what is tension? Tension is 4 times 1.9667 plus 23.6. 23.6. Okay, 23.6. So let's see what we are getting. Okay, let's see what we are getting. 23.6 plus 4 times 1.9667. What is our answer? 31 point. Tension is 31.47 newtons. Happy? 31.47 newtons. Right? Happy? Perfect. So, yeah, we are good now. We are good. So, proceeding. As we proceed now, what do we say? We then say, let's see if we lost anything. Okay, we didn't lose anything. All right. Now, okay. Now, let's see 4.4. What is 4.4? So 4.4 says to us the angle of inclination is decreased to 10. Angle of inclination is decreased to 10. How will the change affect the coefficient of kinetic friction? It will remain the same. Okay, it will remain the same. Why does it remain the same? Because coefficient of friction does not depend. Coefficient of kinetic friction does not depend on the slope, but the surface. Okay, so we're done. So this is now 14 marks. So let's see, the previous question was 19. So 19 plus 14. So that means we were supposed to be done in 33 minutes. We're done in less than 33 minutes. So we are on the right track, isn't it? Perfect. Now let's see. This is interesting. Now we are going to question 5. Is it 5? No. Okay, yes, we are going to question 5. Where do we come from? Here we're coming from question 4. We are going to question 5. Now 5.1. A crane at a building, interesting, a crane at a building site lifts a container filled with concrete and their combined total mass is 780 kilograms. The container is lifted upwards at a constant speed. Constant speed, acceleration is 0. By means of a light inextensible cable as shown in the diagram below. Ignore the effects of air friction. Interesting. Draw a labeled free body diagram of all forces acting on the container as it is being lifted up. It will be tension and what? And the weight. Okay, tension and the weight. So that's it. Now 5.2. Calculate the tension in the cable. So here F sub net is equal to MA. So what is this? Tension minus F sub G equals MA. So remember this F sub G is mg, right? Perfect. So our tension, we do not know what it is. Our mass is 780. Gravitational acceleration is 9.8. Again, our mass is 780, but this is pulled or lifted at constant speed. So it means acceleration is 0. Okay? So tension minus 780 times 9.8. It's 7,644 equals 0. Therefore, tension is 7,644 newtons. That is our tension. Okay? Perfect. 5.3. It says that the crane changes the tension in the cable to 780 newtons. How does this change influence the acceleration of the container? Right? Only increases, decreases, or remains the same. Okay, so what you need to see now is this. Do you guys see that now that your tension has increased? When your tension has increased, remember this guy remains the same. The weight remains the same. When the tension increases, it means your net force increases. Now, as your net force increases, it means acceleration must increase. So your answer is increases. Okay, why? As tension increases, net force increases. Okay, net force increases, and then net force is directly proportional to acceleration. Therefore, acceleration will decrease. This is from Newton's first law of motion. Right? Just like that. Okay. 5.3.2. Calculate the acceleration of the container. Calculate the acceleration of the container So when they say calculate the acceleration of the container, okay, we then need to say, all right, acceleration of the container. Now, remember, this is when the tension has changed. F sub net is equal to MA. What is this? Tension minus mg equals MA. They said the tension is 780, and then the mass is 7,800. The mass is 780. Gravitational acceleration is 9.8. The mass again, 780. Acceleration is unknown. So let's see. 7,800 minus 780 times 9.8. This is 156. Okay, maybe let me not do this. But yeah, this is 7,800 minus 7,644 equals 780. Okay, so this will be 156 equals 780 A. So A it will be 0.2. So A will be 0.20 meters per square second. Right? Meters per square second. Happy? Perfect. Now, interesting. Now, all right. Now let's see. Question 6. Let's see if we have enough space here. All right. Question 6. The mass of the satellite of mass 100 kilograms is orbiting the Earth at a distance of 1,200 kilometers from the Earth's surface. Okay. How does the force which the Earth exerts on the satellite compare with the force that the satellite exerts on the force? They are equal. So our answer is equal to. State the relevant physics law that you applied. This is Newton's third law of motion. Okay. So when body A exerts a force on body B exerts the force of equal magnitude to body A, but in opposite direction. Okay, but in opposite direction. So this is Newton's third law of motion. 6.2. Yeah. State Newton's law of universal gravitation in weight. So, every body. Now, this is where I get tired when I'm in the exam. Everybody in the universe, attracts, I know I squeezed it, attracts every other body with a gravitational force, that is directly proportional to the product of their masses, to the product of their masses and inversely proportional to the square of the distance between their centers. Right? Perfect. Now, 6.3. Calculate the force that the Earth exerts on the satellite to keep it in orbit. To keep it in orbit. All right, to keep it in orbit. This is force equals capital G m sub 1 m sub 2 all over r square. So this is 6.67 times 10 to the negative 11. The constant is given, and the mass of the satellite is 1000. Mass of Earth is 5.98 times 10 to the 24. It is also given in your data sheet. And then now with the distance, remember they said it is 1200 kilometers from the Earth's surface. So I don't mind to write it like this. That kilometer will change it to 10 to the 3 plus the radius of Earth is 6.38 times 10 to the 6 all square. Okay, let's take our calculators. Is this now 6.67 minus 11 times 1000 times 5.98 times 10 to the 24 over 1200 times 10 to the 3 plus 6.38 times 10 to the 6 close square. Oops, what did I do? Oh, minus 11. Minus 11. Okay. So what do we have? We have 6,942.06 newtons, isn't it? Let me quickly show you the constants. The mass of Earth is 5.98 times 10 to the 24, correct? Radius of Earth is 6.38 times 10 to the 3. Of course, you can say times 10 to the 3 times 10 to the 3. So when bases are the same, we add exponents. This is because kilo means 10 to the 6. Universal gravitational constant is 6.67 times 10 to the negative 11, right? So we are good. Let's go back. Okay, so we are good. So what was this? This was 6. This was 6.3. So this was 6.3. All right, 6.4. The mass and radius of planet A. Where is it? Oh, the mass and radius of planet A are that. Calculate the acceleration. That's fine. So we know that what we have, if we have F equals G m1 m2 over r2, let's read the question. The mass and radius of planet A are 7.35 times 10 to the 22 kilograms and 1,737 kilometers respectively. Calculate the acceleration due to gravity on planet A. So what we do, we know that this F is equal to m times acceleration. Okay, so this is the mass of the object times its acceleration. This acceleration is basically the gravitational acceleration at that planet. So let's just say this is our object 1. So we'll then say changing this becomes m1a equals g m1 m2. This is when we find the weight of this is weight of an object at planet A. Weight of object at planet A. Okay, right. So now, as you can see, we will then say the acceleration will then be dividing by m1. It will be g m2 over r squared. So this is 6.67 times 10 to the negative 11. The mass of that planet, they said it is 7.38 1.35 times 10 to the 22. The radius of that planet, they said it is 1,737 kilometers. So I will say 1,737 times 10 to the 3 close square. This is the gravitational acceleration of planet A. So let's go. So what is it? The gravitational acceleration of planet A is now 1.62, okay, is 1.62 meters per square second. This is the gravitational acceleration of planet A. Remember, guys, I know that I'm supposed to be using this formula, but I wanted to show you how we get this formula. We have shown you this in our video of forces, right? You will see it in the playlist. It's gonna show shortly. So, with this being said, our ends here, and I believe you now have an idea of how to solve problems of forces. And remember, you can follow us on your social media because we have introduced WhatsApp channel. You can also follow us on WhatsApp. The link is in the description of this video. Again, in the description, there are links to follow us on your favorite social media. Being it your Facebook, your TikTok, your Instagram. The link is there. TikTok not as yet, but your Facebook, Twitter, Instagram, it is there. And if you're looking for a tutor, you can also hit us up visiting our website. And because you are watching on YouTube, please subscribe. And if this was helpful, please like the video. So, with that being said, it's a wrap and bye bye.